I'd like to welcome Barry Goldsmith, and we had this special meeting on Groundhog's Day just for you. I told them you pointed that out when I invited you, that it was Groundhog Day and how appropriate. So Barry's with the National Weather Service in Brownsville, and he's been with NOAA for 36 years, and he's been in Texas for the past 14. And prior to that, he spent time in 9 years in Tampa Bay, Florida, and 5 as a forecaster in the Baltimore, Washington, D.C. area. That's where I'm from, so we didn't cross paths, but we know the same areas. And then he spent 7 years at the national headquarters outside of Washington. So we're very lucky to have Barry here to give us his take on the weather and climate of the Valley. Oh, you're muted, Barry.
Okay. Apologies there. Yeah, it's funny the way WebEx works. It minimizes your screen, and then you have to go to the top of your presentation to find all the widgets. So I think I found them. And hopefully everybody can hear me. So I need a thumbs up. All right, very good. So yeah, I'm pardon the voice. I've had a little bit of asthma situation, so bear with me. In fact, I'm going to put my Ricola in my mouth so I can get a nice soothing discussion. I even have my Master Naturalist tea mug. Thanks, courtesy, I think, of y'all. It might have been from the other group that I speak to around this time of year too. So um, this presentation is not necessarily new to those who have been here before, at least part of the organizing crew and the team. But for those of you who are new, it should be new to you. So I do change it a little bit every year, but the main bottom line is the same as we discussed the weather and climate of the Rio Grande Valley. So without further ado, we'll get started. Some quick housekeeping. I will try to take some breaks and monitor the chat and see if anybody has any questions in the chat. Otherwise, I guess you can ask them on the WebEx line itself, and I should be able to answer them. So it's going to be a little bit interactive. I have a lot of material to get through, but I should be able to get through it fairly steadily. And we'll take those breaks. You all can ask any questions if you have them, but if you don't, we'll hold them for the end and we'll just continue to soldier on. So without further ado, I always like to start with this one. And it was a Texas weatherman. I don't know if he was a true meteorologist or not, but in the 1920s, he once said, quote, "Texas is a state of perpetual drought, broken by the occasional catastrophic flood." And kind of think it was just an old time statement of, lore in the state. But if you look at reality, especially here in the Rio Grande Valley, over the last 5 to 7 years, let's show you some examples. So from drought, early June 2018 to flood, late June 2018. And then back to drought in early September 2018. It was just beginning to re-dry out for a drought. And then just a few weeks later, we're green again. So there were floods with this one. They were located in the north of Edinburgh up towards the sheet flow area of Brooks and Kennedy County. But I took this picture of Brownsville just to show that we went from drought to flood to drought to green. And you're saying, well, it's only a one season of 1 year example. Well, we went back to flood in June of 2019. We had a repeat event, similar to what we had the year before. And then by March of 2020, we're back in drought across a good part of the valley. And then July 2020, here comes Hurricane Hannah, produces floods across the area once again. And then, excuse me, and then in March 2021, this is a field outside of my house where we were in severe drought. Actually, I think it was moderate drought. But if you went a little farther west and north, particularly out towards the Rio Grande Plains and brush country, it was exceptional drought in March 2021. And you're probably thinking, okay, what else? Well, there's another ellipsis there, and back to flood we go. This was Brownsville, October 2nd, 2021, and that was actually a road on the east side of Brownsville that was now covered in water from what we think was 8 inches of rain in just 2 hours, and a total of over 10 inches of rain. Drainage just can't handle that. So the Texas lore from the 1920s still holds true. So now with that in mind, let's get started with reasons for the particular weather and climate we experience. So geographically, we are a river delta in a coastal desert. So we've all heard the term Rio Grande Valley, and we love that term. It identifies our home here. But in reality, it's not a valley, it's a river delta. And the delta encompasses the drainage basin of the Rio Grande below Falcone Reservoir. And there's little elevation change from the base of the reservoir to the Gulf of Mexico, basically 900 feet between South Padre Island and Jim Hogg County. So a little bit of rise. There are some rising hilly areas in Starr County that match this value here. But again, compared to other parts of the country, for example, California, where you go from sea level to 5,000 feet in no time, we have a very gradual rise. Now, the curvature of the Texas coast creates some microclimate convergence zones, and we'll explain what that is momentarily. And then the Mexican plateau contributes to the desert climate. So let's take a look at Texas overall. The next slide. This is the average annual precipitation. These values have changed a little bit, not much. I think they've gone up a smidge in some areas and gone down a smidge in others, but overall, the last 30-year cycle is about the same. But the bottom line is if you go to East Texas and the Golden Triangle region here near Port Arthur, you have a very tropical rainforest type climate with a lot of rain per year. If you've ever been up there, lots of tall trees, lots of deciduous plant, a lot of green for the most part. But as you move west in the state, you go from that regime to a desert regime in places like El Paso and the Permian Basin. And here in the Rio Grande Valley, we're kind of in between. We are generally on the dry side, but parts of the region are just moist enough to be considered humid subtropical. So that leads me into my next slide, which are the Köppen climate types of the state of Texas. And I've outlined the region of the Rio Grande Valley, and you'll see that the what's called the BSH, or hot semi-arid steppe region, bisects the populated Rio Grande Valley from the humid subtropical region here on the right. And you'll notice this interesting bend in the humid subtropical region that encompasses Dallas, Fort Worth, Waco, Austin, San Antonio, even stretches out towards Abilene and even around San Angelo, on the edge here, San Angelo. You're probably asking, well, wait a minute, why does it bend like that? And we'll go into the answer in the next few slides. I'm going to leave that with you to maybe mull over why there's this bend in the humid subtropical, and we are sitting here in the hot semi-arid region. So it's going to go over the climate of the valley. The lower valley, capital L, which includes Zapata, Starr, Hidalgo, Cameron, Willacy, and pretty much all the area that we serve, including the brush country, is humid subtropical and split into, when you get west of 281/69C, into semi-arid steppe. The terrain here exerts very little influence, does not impede the passage of what's called transient systems from the west to northwest. So if a front is coming down, either atmospherically or at the surface, it's going to come. There's really no influence of that. The Laguna Madre and Gulf of Mexico, though, do moderate the local weather, which produce a pronounced sea breeze effect in the summer and somewhat, I say somewhat, modify polar outbreaks in the winter. We'll get to that a little bit later towards the end of the discussion. But the modified polar outbreaks can be experienced when the depth of cold air is sufficient to move fronts deep into Mexico. So I like to call it a one-sided peninsula. Unlike Florida, where you do have water on both sides and sometimes warm water that can actually impact or moderate the cold air, that doesn't happen here. The cold air makes its move from southwest Canada to the east side of the Rockies. It's got nothing to stop it. It's like a freight train. As you see here, little tiny letters like tomorrow. We'll get to that teaser in detail a little bit later. There is no established delineation of seasons. I said, just feel it out there today. Well, that's true. If you were out there today, it kind of feels like a late spring day, even though the month says early February. That's because we are very close to the tropics. We're at 25.9 to 26 degrees north latitude. And the tropics begin at 23.5, which is about 220 miles south of us, which isn't really too far away. So let's take a look at the rainfall and temperature trends for different stations here in the valley. We're going to look at Brownsville and Mcallen. And this is the 1991 to 2020 sample, which was brand new as of May. We had to change everything over. We used 30-year samples with overlap to account for any decadal changes in the climate without windshield wiping too far one way or the other. I will say this, however, I didn't put the slide in here, but I can show it to you on the web if we have time. The last 10 years, and I'll get to that in a moment, were so warm that it influenced the 30-year value to the tune of a 2+ degree change for many months compared to the prior 30-year sample from 1981 to 2010. So what does that mean in terms of you and me? Well, if you're watching on TV and they say today was 2 degrees below average, right? In the 1981 to in the current sample, that value is based on a higher level, which means that in prior samples, it would have been 4 degrees below average. I guess a better example would be if it was 2 degrees above average back in April using the old sample, and we had a new sample kick in May, then in May, that 2 degrees above average would now be average. And if it's 1 degree above, it would actually show up as below average with the new sample. So you can't be fooled by the rate, the relativity of which cycle you're using. You have to be looking at it as, sorry about that. You have to be looking at it as what are you relating to? And if you relate to the entire period of record, now it becomes more real. So these are our averages here, and the numbers have gone up. This is for Brownsville, the average mean maximum temperature, now 85.4 for the year. That used to be around 83.4 for the year. So it's gone up 2 full degrees. And many of those 2 degree changes were in the winter and in the summer, and not as much in the fall. So let's take a look at the last year that we just had. And this squiggly chart may seem hard to read, but what we're seeing here are the averages in dark blue, actually the dark blue are the observed temperatures. The averages are kind of in this tan color here. And then when you get to the higher than average and near record values, the records are actually the red line. So every time you see a red line, that's a record temperature. And the blue is the same thing on the other end of the coin. Blue is below average. When you see the blue spikes, those are records. Now, when you look at early 2021, you'll see this drop, like drops out of sight here, towards, in some cases, to or beyond the record for about 10 to 12 days here. And that was our culmination of the killing freeze in February. But in January, it was kind of near normal. In March, was kind of near normal or near average. And then when you get into the summer and especially the fall, notice how we start poking into the red a lot. These are the temperatures at the peak level, poking more into the red and barely poking into the blue. And you have some breaks where it pokes equally into the red and the blue. And then when you get into mid to late fall, it's basically all into the red. So at Brownsville, when all was said and done, we ended up 5th warmest on record, going back to 1878. And precipitation was pretty wet, which I'll show you next. So it was wet in 2021. In Brownsville, we had 2 specific events that contributed, actually 3, one not shown as May. We see the increase here in green, the rise, that was wetness in May. But the big hitters were this early July summer soaker, a month that does not get a lot of rain normally. We got plastered in the first 10 days of the month. It was good rain. And then we had the October flood in Brownsville. There's that spike right there. It's a 2-day spike. And in the end, when you add it all together, we're well above the average line, which is this dark brown tone. And of course, the blue is the all-time record. So we weren't near the all-time record, but we were on the way there. So sure enough, when we averaged it out, we ended up being in the top 10. But most interesting of all from the climate data, we'll show this for Mcallen, but we'll go over more quickly, is what we've seen in the last 8 to 10 years. So we all know that we are warming. That is a fact. And the accelerated warming generally began in 1980 and has continued to this day. But the most rapid acceleration began in 2011 and has continued pretty much unencumbered until 2021. And we can show that clearly on the all-time record warm years. 8 of the warmest years, going back to 1878, that's 142 years of record, occurred in the past decade. So let that sink in for a little while. All years in the top 10 occurred in the 21st century. And 2021, which started cool, as you saw in that previous slide, recovered quite nicely in the last half of the year and ended up right here at number 5. So where will 2022 land? Well, we can't say number 1. It's been some pretty warm years of recent memory, but will it land in the top 10? It's got a pretty good chance to do that. We'll explain why a bit later on. So for Mcallen, same deal. We've warmed the average temperatures from the last 30-year cycle to this one by about 2 degrees. And these are the raw numbers. And notice now that for the month of August, and I'll point this out here, hopefully you can see my mouse, is now averaging 100 degrees when you round it up per day. We didn't have that 100-degree benchmark on the averages before. Now we have over 30 days when you stretch it back into July. I think it's July 30th, not 30 days, I think it's 22 days. July 30th to August 18th are now 100 plus. And it doesn't fall much the rest of August. So there's your high temperature, average maximum temperature for the month, 99.6. So that clearly, I'll go back to the slide, matches what we're seeing here in Brownsville, and we'll quickly go over Mcallen's example shortly. So in 2021, it was wet in Mcallen too on different dates. We'll show those momentarily. But despite the fact that they had a cool start as well, and they had the rain in summer, that June and July rain, you'd think, oh, it's going to keep the yearly average from coming anywhere close to an all-time record, but no. The autumn came through for Mcallen as well. And by the time we were said and done, it was 15th warmest on record with 80 years of record. So it's in the top echelon. It's in the top quintile. As far as the rainfall, there were multiple examples here. They did not get the October slam, although it does show up right around here as a slight uptick with the September 30th, October 1st event. But the big ones were in May. It was the second wettest May all time. And there's that rise right here. And the second wettest July on record, once again, July 6th through 9th, it got pretty darn wet in Mcallen. And at some points, the totals were actually above the all-time record, heading all the way into the latter part of September before tropical cyclones from the past took over for the all-time record. But it wasn't too far away, which is why we mentioned it ended up 6th wettest on record. By the way, all-time records for rainfall where Mcallen does not have a sample, because it didn't go back to the 19th century, was 1886 and 1887. If you remember, 1886 was multiple hurricane strikes nearby. over 55 inches of rain in back-to-back years. Imagine if that happens today with all of our developed infrastructure. Yikes. So Mcallen doesn't have those records because it only goes back to 42. But here are our temperature records again, showing many of them in the 21st century. And all but 1 year in the top 15 are in the 1998 and beyond period. So it shows up in Mcallen too. 9 of the top 10 years of the 21st century and 7 in the past decade. Brownsville was 8. And 2021 also started cool. And you can see here I've showed the 10 to 20 ratings here. And there's 2021 ranking up there at number 15. Once again, though, the curves, these regression curves, and this other one known as a Loess curve, which is a statistical term that allows for the 3-year samples to get involved here and create more of a broader sense of overlap here. There is a little dip here in the 1970s, but then from the 80s on, once again, you get the steady rise that becomes accelerated once since the 2000s, and especially since 2013. So it's showing up not only here in the Valley, but it does show up in other locations in the country. So before I move on to the next slide, are there any questions? And I believe I can monitor chat. So let's take a quick break for questions. And I see nothing in chat yet, but you're welcome to plop it in there or ask me directly. Let's take a minute. And if there's no questions, we'll just march forward. All right, going once, going twice, we're going to move on here. So, moving right ahead, what's most frequent here in the region? Well, strong winds. I mean, we call it the valley wind machine, which we'll explain shortly. And then heat and drought. I mean, after all, if we're a semi-arid, hot steppe region, you can expect to see heat and drought come back and come back and come back. But we also match that with locally heavy rainfall and flooding, as we showed earlier on. State of perpetual drought, broken by the occasional devastating flood. And then lightning. Believe it or not, lightning can be frequent, even though rainfall may not be. When it rains here, more often than not, it comes with some hellacious lightning. So I wanted to put that in there as a more frequent event, even though it's not necessarily frequency of rain versus lightning. It's when it does rain, and it rains hard, it usually comes with crazy amounts of lightning. As we saw last May, we saw it in July, and we really saw it early October down here in Brownsville. Less frequent, tropical cyclones. You're probably scratching your head saying, wait a minute, we're in a hurricane zone. Well, we are, but we also have factors that inhibit not only the formation at times, but the continuation and the movement because of both geography and the nature of where we're, well, it's all geography, but it's also some other factors too. So they're not as frequent as you might think compared to these other ones. And then cold weather. I mean, yes, we're seeing some this January, but overall, we typically wait 3 years between notable freezes or even notable like minor ice events. It's not like it's an every year occurrence or a multiple time per year occurrence. So the wind. Let's talk about the valley wind machine. Have you ever noticed that a lot of trees here are stunted? Aside from some Italian cypress and Australian pines, which are not native, and you may see a few sable palms that can grow. Most of the trees here are not growing very tall. That's because there's just too much wind too often. It does affect bird and insect movements day to day, for sure. When it's blowing, it's going to move those fauna around. And it does alter the moisture forcing mechanism. So here's the example. We have the cooler waters of the Gulf, and cool is relative compared to land, of course, where you get a normally occurring high pressure zone, not necessarily this close to the coast, but generally in the Gulf of Mexico. In the lee of the Sierra Madre, however, where air downslopes and heats up, when you have hot temperatures at the surface, what does that mean? That means heat's rising. And when heat rises, the column over top of you from the surface up loses pressure because you're losing that heat column. The column is being evacuated by the heat. So your pressure goes down. And as we all know, air flows clockwise around high pressure and counterclockwise around low pressure. and the Rio Grande Valley is right in between, which is why the predominant wind is from the south or southeast. And you notice that when trees are bent over, they typically bend from south to north. Now, the pattern of the wind machine is such that when it really starts to blow, particularly in the late fall or mid-fall through the mid-spring, the atmosphere contributes its own little piece to it. And what we see here is a steering flow of the atmosphere showing a broad trough of low pressure or dip of low pressure in the atmosphere, and a broader, flatter ridge of high pressure in the atmosphere across the eastern Gulf out to Bermuda. And in between, you have this pretty fast southwesterly flow high in the atmosphere. And what does that do to the low-level winds? It enhances what we already have. So instead of getting 15 to 25 mile per hour breezes, in a case like this, you get 25 to 40 mile per hour winds, sometimes gusting over 50, and that can cause more problems, not only with broken branches and limbs, but it can change the way birds and insects migrate or move around on those days, and it can certainly cause issues to power as well. So let's talk about heat. We have a high sun angle, so no matter how you slice it, we have a high sun angle just because we are much closer to the equator and the Tropic of Cancer than we are to the pole. So in the wintertime, we'll get slow evaporation rate with light wind and high humidity, but notice the key is slow, not no. Some places up north, when you go to, say, Seattle or Nebraska, or head on across to Chicago or Boston, they have no evaporation rate. In fact, they tend to have more moisture increase rate, which is the reverse of evaporation, and they get wet during the winter, late fall or spring, but not here. We're still slow. When we get moderate evaporation rate, we see moderate wind, low humidity, or strong wind and high humidity, and that's common in spring, but we can actually get moderate evaporation rate throughout the entire winter and spring and fall if the winds, humidity, and temperature are sufficient to create it. And high evaporation rates typically occur with strong wind and low humidity, and they are common in fall and spring and obviously in the summertime. But in the summertime, you may not get the winds or the low humidity. So while the evaporation from the sun can be relatively high, the total evaporation rate is actually higher in general in April and May, and again, sometimes in October, than it is necessarily from June to September. But every so often you get a case in June, or maybe July, or maybe September, where you get that combination of the heat and the wind and the sun angle, and you have maximum evaporation. So this happened in 2017, superheat blast. These were the actual temperatures, not the heat index, actual temperatures that day, over 110 in the Mid-Valley, and even in Brownsville it got to 100, and even down by Bayview it got to 102. And so we had several new records set. Humidity was low out to the west, down around 25%, and there was lighter winds, fortunately, because had there been stronger winds, not only is that an evaporation problem, it's a fire weather problem or fire danger problem if a fire starts. Well, here's one in July. So we got a situation of dry, hot weather. I don't believe this came with wind, but sometimes it does. In 2009, we had multiple cases in July, similarly hot, that came with wind. And we broke records here in mid-July, once again, across all of South Texas. And finally, Labor Day weekend in 2011, we had a record event. This was actually the same weekend that we had the Bastrop fire up between Austin and San Antonio, which burned over 100,000 acres and I think burned over 500 to 1,000 buildings. And what made this happen was a tropical cyclone. It was Tropical Storm Nate that was making landfall in southwest Louisiana. On the backside of that and the front side of high pressure ridge in the atmosphere, we had incredible compressional heating, meaning the air compressing, warming up, and then drying out. And when you combine that, you had the entire state of Texas very dry, very hot, on top of the fact that we were already in extreme to exceptional drought across most of the state. So these were all new records that were set around Labor Day weekend in 2011. So let's talk about evaporation rates and high to extreme. When we get to that level, now we start looking at drought. And not only drought, but drought rapidly intensifying, known as a flash drought that can become a medium-term drought that's also intensifying quickly. So how do we get a flash drought? Well, positive feedback loop, dry ground, high sun angle, increasing wind, creating more dry ground that's already feeding off the high sun angle and the increasing wind. That is what we start to look at for creation of a flash drought, which can occur in a matter of days, if not a week. The summer of 2009, we had a flash drought. We had all-time record heat across the valley. The average high temperature in Mcallen that month was 104 in July and I think 103 in August. Crazy hot. Hotter than anything we've seen by far. It stressed ranch livestock. There was lack of wildlife refuges across the valley and beyond. Then for 2011 overall, it was the record driest water year in Texas ever. And it followed one of the record wettest water years in 2009, 2010. So what a switch. $5 billion in agriculture loss and 25 million in the valley that we know of. It could have been quite a bit more. And this drought became a fairly long-term drought that continued into mid-2013. So I noticed I put 2021 here as question marks. Well, as we just saw before, 2021 ended up being fairly wet, but not at the beginning. We actually went to severe to exceptional drought, which is the worst number, level 4, across parts of the valley and the brush country in April. And then I mentioned before, the rains came in May, and they didn't really stop until after October 1st. And by then, we were largely into a moisture surplus, although locations out in the Rio Grande Plains of Zapata and Starr County and the brush country out there missed the boat on some of the heaviest rain. So while they lost their extreme exceptional drought, level 3 and 4, they kind of hung in there with dryness and moderate drought, including right now. So they're an area we're watching very closely because why do they matter? Well, if it doesn't rain much out there, we don't get a lot of water into Falcon Reservoir. And that's been the case for the last year. So while the valley's been flushed with rain, the Rio Grande Plains have been flushed dry. So let's talk a little bit more about drought. We live in a desert, as we mentioned before. Erratic rainfall is normal, again, a coastal desert. La Nina years tend to be drier for the valley, but there are exceptions. Remember, thunderstorm systems that develop because the atmosphere wants them to, and or a tropical cyclone, is going to provide the kind of rain that busts your drought. And so the La Nina year that we just went through, yeah, it started that way in spring, but by May, we turned on a dime with all that rain, and that kind of ended it for most regions. And we're still seeing just-in-time rainfall here in the valley. Again, El Nino years tend to be wetter, especially during the winter. I mentioned here not always see this year. That year mentioned here was 2017-18. It's not now. It can be detrimental to Atlantic hurricanes, but like I always say to people, it only takes one to make your season. Again, that's not the case now. I forgot to update that slide. But I wanted to go back and quickly look at the wet to dry situation from the water years, just to show and build the concept again of Texas is a state of perpetual drought broken by the occasional flood. Sometimes that perpetual drought or flood can last a while. In 2009, 2010, which was an El Nino season and water year, we had record rainfall. We had rain in the fall and winter from November through January of 2009-10. Then we had a big rainfall in April. Then we had rainfall in late June, early July from Hurricane Alex and Tropical Depression number 2. Then we had sporadic showers and storms after that, and then more rain of note that neared records in September of 2010, which finished off your water year. So there's record to near record rainfall. Look at these numbers. This is very Houstonian, or not even too far away from Port Arthur. And then 1 year later, water year later, we had almost no rain. So out there in La Jolla, where some of you may live, in McCook, certainly Mcallen, under 10 inches of rain. This is desert dry. This is more akin to Palm Springs, believe it or not. It's actually drier than Tucson and Phoenix for the year. And amazing how it turned on a dime. And sure enough, the drought condition across the state did the same thing. So in October 2010, at the beginning of the cycle, we were in the white. Almost the entire state was white, meaning no drought, in fact, moisture surplus. 1 year later, almost entirely maroon, which is 95% of the state was in exceptional drought, which is the worst case. And that's when you start to see water crisis. You start to see cattle dying. You start to see demands for water supplies for both agriculture and municipalities. It was bad. But slowly but surely, we got some rain coming back in 2012, 2013, and 2014, although parts of the state remained in drought conditions throughout that entire period. So this was last year in 2021 with the drought monitor. So I'm going to have you imagine what it looks like this year. I didn't have a chance to get the slide in because I was busy working the weather coming in the next few days here in the valley. But January 25th, 2022, and the drought monitor that will come out tomorrow, I'll show a level 1 drought, which is this light tan area across the Rio Grande Plains, and everywhere else is pretty much drought-free here in the Rio Grande Valley. So a real difference from last winter and especially spring to where we are now. We've had a lot of just-in-time rain, which is great, but can we continue to survive on just-in-time rain? Will that start to go away? We'll talk about that a little bit later. So here's 2022. I do have it. So 2021, the valley is dry. The Rio Grande Plains brush country are dry, and so is the Permian Basin. In 2022, now it's North Texas, Central Texas, and the Permian Basin, and a little bit of here in the South Texas, looking at the Rio Grande Plains brush country, not too far from our valley region. But look, the valley is okay. And you have to go into Starr County before you get into what's called abnormally dry. And in fact, we're actually reducing the abnormally dry area tomorrow. But this area of moderate drought will continue in Zapata County. As I mentioned before, they just missed the boat. Every time they could miss it, they did. And while they got some rain to help reduce the drought, they never quite lost it all. So, shifting from drought to flood. Any questions before we move on drought? Okay.
Did you see the question about what impacts are wind turbines having on our ambient temperatures?
I have not seen that one. Hang on. Oh, there it is. Oh, I just saw it. Okay, Tony Rice got it, Tony, pretty well. The answer is, let me kind of think about this a minute. The broad answer in terms of how the bigger atmosphere operates, and we're talking the atmosphere up to 50,000 plus feet, is no impact at all. I mean, when you're talking about small plots of land and the wind turbines that are roughly 100 feet, maybe 150, 200 feet, and the atmosphere is a 50,000 foot pancake versus a very thin crepe, it's not going to impact the way the atmosphere flows at all. Now, regarding the actual ground, sorry about my dog in the background, there's people walking by, so excuse me for that. But speaking of the ground temperatures, perhaps right around the sites themselves, there could be some minor influence, but overall, it's really not going to change things when it comes to mixing of the atmosphere in the broader sense. I mean, you literally have to cover every single, square foot of land with wind turbines to impact the surface and maybe cause a little bit of a ripple up to say 1,000 feet, maybe 1,500 feet, but that would be about it. So the answer is in general no, but again, if you cover the earth with it, you might get some local impacts on temperature, but really not enough to make a difference in what the atmosphere is going to do. Kind of like when I was a kid, I used to think, oh my gosh, these diesel engines putting soot out there, are going to make my little local neck of the woods not get as much snow. I was a big snow lover when I lived up in the DC Baltimore area. And when we had these, waiting for a bus or being on the road and seeing the trucks go by, like it's going to ruin the chance for snow. No, it's not. Not at all. But in the longer range of things, when you put so much carbon in the atmosphere and it's measured globally, that does change things. That's a difference. And does that start from some of those small emissions? Yes, but it takes a lot of them to change the outcome of a local atmospheric event. So no, those trucks were not going to stop the blizzard from coming, just like the wind farms are not going to really have these perceptible change in temperature. So thanks for the question. We'll move on now to rainfall and floods. And I hope everyone can hear me. Sorry about my dog in the background, but I've got a high ceiling in another room and he's barking at people going by. So let me see if I can take care of him. Give me 1 minute to take a quick break. And I'm going to see if I can get him into another room temporarily so he can be quiet and y'all can hear me. So sorry about that. We'll take a really quick mute myself break and we'll be right back. Thanks.
Thanks, Barry. We did have another question, and it may be very similar to the one you just answered, and that is, does asphalt, concrete homes, etc., increase the temperature?
Okay, so I should be unmuted. So again, teleworking and dogs, I'm sorry about that. But yeah, to get to that question, and I don't see it here, but there is something called the urban heat island, and that is real. If you pave over wetlands and you pave over grass in a large scope, such as New York City, Chicago, Washington, Baltimore, even parts of Mcallen here in the valley, that does absorb more heat and it does contribute to ground level or near ground level temperatures. So that is a real thing. But when it comes to looking at the overall climate of a region or a nation or a globe, that is all factored in. And in fact, values that are exceptionally high because they are sitting on an urban heat island are usually removed from those databases when you look at the larger scale global or even regional climate. And now that said, when we do comparisons, we make sure we do an apples to apples comparison. So we actually updated the Mcallen database for the 30-year sample because it's a very stable site. And it's measured against Mcallen Airport. So while it is a heat island that's higher than the nearby location at the water plant, which is not quite in the heat island as much, there's a difference there because that's a different type of apple, but the same apple as the airport. So those changes are the same. We saw the changes at the nearby site were about 2 degrees too. So just, the heat island effect is what you're seeing with asphalt over a fairly decent sized geographic area locally. And here in the valley, I think the best example of heat island would probably be Mcallen, maybe a little bit in Brownsville downtown and Harlingen, but where we are at the airport, we're still pretty rural, so there's no heat island there. So let's talk again about rainfall and flooding. Valleys of river delta, low-lying flat, torrential rain has nowhere to flow. Soil type is impervious, it doesn't drain very well, and it increases, unfortunately, the hatching of vectors, mosquitoes and other disease-carrying insects. So we've had in the valley everything from West Nile, dengue, Zika, chikungunya. They've all been observed here in the region. And of course, heat, humidity, and standing water can increase the amount of microbes that are harmful to us and to wildlife because we don't drain very well naturally. So if you ever hear the terms from the Weather Service about flooding, let me kind of run over them quickly. There's something called a flood or a freshwater flood, like Hurricane Dolly left, which we define as 3 feet or more of standing water or slightly lower amounts that damage homes and businesses from heavy rainfall. It's not moving. It's just standing water that rises and rises and rises. And we'll show you an example of that with Hurricane Dolly next. A river flood is like it sounds. The river floods, a gauge gets exceeded for flood stage, And because of that, it now floods either the nearby marshland or wetland, or if it's enough, it could flood roads nearby or ultimately a city. So that's what we start to see across river flooding. Now, the Rio Grande is a whole different animal, and that's a whole other talk that would take me about 45 minutes to get through. So for sake of time, I'm going to move along here. Here's the example with Dolly, July 25th, 2008. You can see it's standing water, it's high, and it's flooding all these areas. This is not a resaca. This is just a detention pond that overflowed. A couple feet of water, maybe 3 feet on the road, and these homes have some water in them, and that would be considered a freshwater flood. Another example happened here in Willacy County. I like to call it Lake Willacy, from 2015 when we had, I believe it was 14 inches total in a matter of 2 days. One was 9 inches from a thunderstorm, which just kind of parked there. And then the remnants of Hurricane Patricia came through 2 days later, dropped another 5 inches or so. And it was just too much for the impervious soil to take. And not only that, that impervious soil had been plowed over because the season harvest was done. And so it was ripe for just water to pile up on it. So these homes are now islands, or these little plots of land, and some of the buildings are flooded from what I saw in the survey I did. Urban flood is the most common thing we'll see here in the valley. All these examples were from 2015, but we've had a number of them since then. 2018, 2019, 2020, and 2021, for example. Here's Westgate in Weslaco along frontages, a known poor drainage area that hopefully will be fixed at some point. But here's Brownsville on the west side near a subdivision known as Galaxia, where you can see this water is up to the hood of this car, meaning about 4 feet. And then here's a resaca that typically overflows onto a park area in Brownsville. So these are all examples of urban flood, but some of them are bad enough to be considered life-threatening. So those are the ones we issue flash flood warnings on, because they occur in a flash very quickly, even though the water is rising more vertically than flowing horizontally. The Rio Grande can flood, and when it does, it's basically related to how the dams are operating. So before the dams, the Rio Grande averaged flooding once every 10 years, which is actually fairly frequent. But once the dams were put in place, we were able to control that water and keep it contained in the floodway, known as the Flood Control Project. So since the dam has been in place, we've had these values of water at Rio Grande City. And with Alex, we got into third place, and other events have not been as much since then because we haven't had a lot of rain flow through that area, because Patricia was the last one in 2015. So at Lower Brownsville, that's when you have water flowing. Some of that may be controlled by releases at the dam. Other water may just flow from the heavy rain nearby. You get a big rain event in the Arroyo Colorado, a big rain event right along the river at St. Mercedes, that water will flow into the Rio Grande, but the values of the heights will usually not be anywhere near this high. This was due to, in Alex, this was due to, let me try again. The value here at the bottom is from the flow out of Falcon Dam that was released into both the US and Mexico after Hurricane Alex. And then near San Benito, same deal. We had 54.41 feet due to water being released from the dam, flowing into the floodway, but also a share released downstream the Rio Grande, causing the values to be high. But one thing to note about all these gauges here, they are all levee protected. So it's very hard to get a flood to go overtopping the levee. However, if you're not protected by a levee, you will flood. So in Starr County, during the Alex event, the county flooded near the river, but it did not reach into Rio Grande City because when they released the water out of Falcon Dam, they released enough not to get into the city of Rio Grande City or the city of Roma. But there were some neighborhoods on the near the river that did have some issues there. Up in the upper right here, Chimney Park is inside the levee. It's on the west side of Mission, and there's a lot of nice community center here, but a lot of mobile homes and RVs. And sure enough, they flooded from the river because there's no levee protection. And the share that went down the Rio Grande, unfortunately, was too high for what they could handle. But the floodway takes a lot of the water. You can see here near Mercedes, if you've ever driven across between Westlaco and Mercedes, you'll see that big open expanse in the bridge going over it of basically hay, right? And sometimes there's cattle in there. But when they open up the floodways and push this water into the US side from what's released out of Falcon, and perhaps released initially out of Amistad, they fill the floodway up, in this case 60% of freeboard, and the road is fine, the bridges are fine, the communities are fine, because the levee is protecting them, but the water is flowing through from, in this case, south to north, and ultimately goes out into the Arroyo Colorado and into the Laguna Madre before flowing into the Gulf of Mexico. But we can get an event that can flood areas without having a name. And so this is the Great June Flood of 2018 in the Rio Grande Valley. And there are actually people not shown here that are walking through this shoulder height water, which was 4 to 5 feet. This was actually in Mercedes. There was just a feed of tropical moisture for several days. And as you know, being close to the tropics, it doesn't take much to get it very wet here. The rainfall totals in those areas range from up to 18.31 inches in Mission. We had nearly 16 inches in Santa Rosa, 16.5 inches in Harlingen. And all these numbers, by the way, are not too shy of what we had with Hurricane Beulah in 1967. So to see freshwater flooding, again, no river here, just no drainage and rain falling too fast in just a few hours, 3-4 inches per hour for 2 or 3 hours, that's not going to be able to be handled by most drainage systems, not only here but elsewhere. There's the rainfall I mentioned. And the next slide is a video or a satellite video just showing that there's no hurricane here. So slowly but surely, this upper level disturbed area, all the reds and yellows and oranges are heavy thunderstorms, but there's no organization like a classic hurricane. So it's slowly migrated westward. You can see the flare up when it runs into the convergence of the land. Day 1, there's another one coming up on day 2. So it quiets down overnight in the early morning, and by late afternoon, overnight again, boom, another flare up. So this is June 19th, June 20th. And then the final one here, June 21st, was the Mcallen Mission event. I think that's actually the afternoon of June 20th. So let's get to June 21. I think that's going to be this one right here. No, that may be June 20th. But either way, you can see over and over and over again, it just basically, wash, rinse, repeat, wash, rinse, repeat. I mean, day after day, for 4 days, we had rain here, and it added up to the flood that you saw. So you don't need a named storm here in the valley to produce a hurricane. So like I say, where's the tropical cyclone? There is none. Again, nowhere. So on radar, the big event was June 20th from Westlaco to Mercedes. And this event started at around 3 in the morning and peaked out between 8, 9, 10 in the morning. But look how much red is on the radar and how long it goes and how far it extends. But the big event was with those dark red clouds you saw before right in here. And now that you're still seeing the yellow and orange, it's still raining pretty hard, just not as torrential. But right in here, we're getting rainfall rates of 3 to nearly 4 inches per hour for 3 hours straight. And it was an amazing event for the region. In fact, it was known as a 1 in 1,000 plus probability event to hit the region. So some quick stats from it. There's your numbers, 11.36 in Westlaco in 3 hours, 2,500 homes and businesses had problems. All schools in the Westlaco district flooded, and nearly all the school bus fleet had water damage or destruction. And this stream gauge here at Arroyo Colorado, which is not part of the floodway system when it's not activated, it just gets water from nearby drainage, literally had a value of 23.98 feet, which was the highest on record without having any water diverted into the flood control system or the floodway upstream. And again, I could do a whole talk on the floodway system, but you get the idea. It was just from torrential rains in a short period of time adding up quickly that caused the issue. Now, if I show this to anybody outside the valley, they're going to say, that's got to be Houston with Hurricane Harvey. Look at all that neighborhood flooding. But no, it was a combination of the 4 to 5 inch per hour rainfall rates for up to 3 hours with drainage system unable to handle the runoff. So we had 3 to 5 feet of water depth common for Northeast, West Laconia, and Mercedes, peak of the heavy rain. But there's good news. A $190 million bond was passed by a 2/3 majority that fall of 2018. And embedded in that were 37 new projects to help improve drainage across Hidalgo County. And one of those projects includes helping this neighborhood out. So they've done some repairs here and some drainage fixes. It has not been tested. But I'll be very curious to see if the water levels are lower, if we have a similar event in the future after the improvements were made after year of flooding there. So once again, Vermont Avenue, Mercedes, here are those men walking shoulder height water. They shouldn't be doing that because the water is very dirty, it's very high, and it's also flowing a bit. So why is that interesting to see this picture? Because the next slide shows that 1 in 1,000 year event right here. So 1 in 1,000 probability event. Known as the 1,000-year return frequency. I do not like to use that term because if I gave you a quiz and said, how often have we had a 1 in 200 return frequency event in the last 5 years? My answer is 4 years in a row. Amazing, right? 2018, 2019, 2020, and yes, 2021 in the West Laconia Mercedes area. It's amazing, but that's why I don't like to use the term year. Because if people think it's going to be 200 years between floods, they're whistling Dixie on that one. So you can see the numbers here. Even the 1 in 50 probability recurrence for 11.5 inches in just 3 days happened in 3 hours. Wow, that's pretty amazing. It just goes to show what happens when you're near the tropics and the atmosphere wants to play in what I call the devil's sandbox. So don't worry, I'm a little shorter on time, so I'm going to go through some stuff faster here. Another way to look at it again on the curve chart here, you can see the West Laconia Mercedes event is above the 1 in 1,000 probability event here, looking at these durations and these return frequencies. So sure enough, that event ends, but it leaves old boundaries around, and now we get convergence across Cameron County on June 20th, literally a day after we had almost the same thing on June 19th. And after those 2 days, the drainage in Los Fresnos and locations east of Los Fresnos couldn't handle it. And now we have 2, 3, 4 feet of water that just can't move anywhere by the late afternoon of June 20th, which carried on into June 21st. So 2 separate rainfall events added up to 10 inches, but each one had around 3 inches per hour, 2 to 3 inches per hour for 2 hours. And again, the first day primed the pump, got things too soaked for any absorption. And then on day 2, it just went straight into flood. There was no chance to go and absorb into soil or into drainage. It just went right to flood. So a 4 to 6 inch event that occurred on June 20th went straight into rising water. And then Mcallen, Michigan got hit the day after. This was a crazy week. A line of rain formed up that initially we thought was going to stay out here in western Hidalgo and cause more problems for La Jolla, for Sullivan City. But then the convergence zone slid eastward, and it ended up getting into the population of the Mcallen, Mission, Edinburgh region. And ultimately that, falling on top of rain that had fallen the day before in the morning, produced this on the right. So southwest Mcallen, poor drainage, 3 to 4 feet of water, some of that getting into homes up to 2 feet. And you can see the Vactor pump out there to remove the water. So yeah, it was pretty crazy. The survey showed June 22nd, the runoff. And then this was a drone footage in a neighborhood called Country Meadows Estates on the Mcallen-Edinburgh line from that same event. Once again, primed the pump the day before, nowhere for the water to flow. But what happened here specifically was a drainage canal just to the north of the neighborhood, not shown, overspilled its banks and caused the problems you saw in this neighborhood, where several homes did have water in them and had to bail water out of them and probably call insurance for thousands of dollars in damage repair. So we measured the rain, not very accurately. Here's 3 feet of water. And this is on the day after, but it's all been now drained out. But during the event, there's the gated community of Country Meadows Estates, and the water is flowing through it. So you think it's all done. We have 1 year of flood, we're good to go. Nope, 1 year later, June 24th, 2019, we do it all over again. This photo was taken in was taken in Harlingen for that event. And actually, let me see where this was taken. No, this was actually, I think, from Mcallen. Nope, no, this was actually Harlingen. That event hit a little farther east. Mcallen, Michigan got hit with rain, but not as hard. But if you were to do comparatives from June 2018 and 2019 in this particular neighborhood in the west side of Harlingen, the Combs-Harlingen area, it would be amazingly identical. And quite scary to think that you have two 1 in 200 to 1 in 500 events in back-to-back years. But we did. And there it is. There's that area of very, very heavy rainfall, 10 to 12 inches. We had a report, I think, of near 15 inches at Santa Rosa, which is right over here. The bottom line is this area also maxed out on the June 2018 floods, in addition to places farther west, but they got it 2 years in a row. And this is what it looked like on radar for that event. We started the day with tornado potential in Kennedy County. We had 70 to 80 mile per hour wind gusts come down through Willacy. They eventually lodged into southeastern Hidalgo. That linked up with other storms that were moving northward out of Mexico, a sea breeze from the east, and we got this. Red on the radar for 6 straight hours over that area that had gotten hit just 1 year earlier. It resulted in the flood that you saw. On satellite, this is what it looked like. You see, it's all black here, but as the big blossoming complex of storms develops, you see the black show up on the borders, and where it's white, it's just dumping rain. That's a big complex of storms that lasted for days and days. Again, no name, just a heck of a lot of rain over the course of literally 6 hours. In some cases, nearly 15 inches of rain. It does not take a hurricane to make it rain really hard. But because you asked about hurricanes, 1 year later, here comes Hurricane Hannah. And guess who gets hit again? Santa Rosa, Elsa Edcouch, La Feria, up towards La Sarda in Willacy County. It's just like they can't buy a victory here. And they got nailed again by the backside and the feeder bands, as well as the inner eye wall on the east and south side from Hurricane Hannah. And here's Santa Rosa, 15.49 inches again for a third event, third year in a row. And this time, Mission Mcallen got hit again. So that was the second of 3 years they got nailed. So you kind of see the south end eye wall, not the north side. South end was where all the big rains fell. There are reasons for that we don't have time to get into. So we'll go quickly through hail and windstorms. Favors mid-March through the end of May. Large hail more common than damaging wind here, barely. Damaging wind has more potentially devastating impact. And damaging wind has and can reach 80 mile per hour or higher. This is what I call last stairs standing. This was in a colonia north of Donna. You can see the remains of this home blown downstream. The wind speeds were below hurricane force for this particular building in the colonia. We're working now to help build resilience in these areas. We know that there are still thousands of structures not able to handle this wind, but we also know that there's a way that they can spend not a lot of money to do a lot of fixing to bring the wind speed tolerance closer to, say, 90 to 100 miles per hour rather than this. So we got some work to be done, but we're starting that work this year and hope to continue it for the next few years. This is a better built building, but still not great. Again, below hurricane force winds took part of the roof off. And this is my favorite for bad reasons. This was a thunderstorm squall line, mini squall line, that ripped through the Mission Grande area on May 31st, 2016. We estimated the winds at 85 to 95 miles per hour. You're probably thinking, oh my gosh, look at that. It's cinder block, it's concrete. It should have held, but it's destroyed. This was a $5 million building for the city of Grande to be used not just as a gym, but as a safe shelter, a safe room during a hurricane. It didn't make it through this storm. Why did it fail? It failed because if you look real closely, you see these, stripes here of construction, and you see a longer version of it at the end. This is called a bond beam. Well, this particular bond beam was not connected to all that cinder block and rebar below it. Well, Big Bad Wolf says, I'm going to huff and puff and blow your house in. And oh, by the way, if you're not connected correctly, I'm going to make your house a straw house and blow it to smithereens. And that's exactly what the big bad wolf did in this case. So build better, build stronger. This is my fear event for the Valley. We actually have an exercise that we created for this event. These were gusts over 100 mile per hour across the northern third of Hidalgo County on into southern Brooks County. It missed the big populations as it weakened moving farther southeast, but imagine if this wind had hit those colonias that we showed earlier. We would just be talking about obliteration of buildings, but if it happens in the evening, we're probably talking mass casualties. So we got to do some work on fixing this and also having places for people to go, because even if we strengthen the homes, we might not strengthen them enough to withstand this kind of wind. And oh, by the way, there's not a lot of time on an event like that. It's not like you have a day or two from a Category 4 hurricane bombing in on you. It's a squall line that may be developing just 2 hours earlier. And so we need to find ways of getting people to safety. Hail, this is the Mcallen hailstorm of 2012. Literally scared the pants off the people from Topeka, actually southern Kansas, who had been through bad weather, tornadoes, big ones, big hailstorms. These people had to go through 45 minutes of this, and they literally thought that their lives were going to end. And it was a bad event. $660 million insured at the last check was covered, but the time we wrote this, it was in the quarter of $250 million. But this became nearly $1 billion event in 2012. Other hailstorms, 2017 in Rio Hondo. And now we'll move on to lightning. Again, infrequently through the year, I'll show you that map in a moment, but the stronger spring storm can produce incredible amounts of cloud-to-ground strikes, whereas sea breeze storms are not going to do it. But lightning can provide additional nitrogen and actually spur the quick growth of grasses. So in some ways, a good lightning storm, not one good enough or bad enough to produce damage, but one enough to produce some nitrogen in the air, can help your grass grow. So here's your average lightning strikes per square mile per year. And you notice that Houston gets creamed, as does the Florida Peninsula, where I used to live for 9 years. But here we're only down to 1 to 2 or 2 to 3 per year per square mile as a flash density. But as I mentioned before, some of that is factored into those big complexes of storms that come through in May, sometimes in October, sometimes in June, that create incredible amounts of local lightning, that stuff that I've never seen before, even living on the west coast of Florida. So let's get to hurricanes now, and after that we'll take another quick break, and then we'll finish up with some forecast information for the upcoming season. So disruptive to nature, long duration flooding rains or wind. We've already seen that with Hannah and with Dolly. We can have storm surge and salt spray temporarily destroying habitat. Animals and birds will actually sense arrival of hurricanes well in advance. They do a much better job than humans these days, because after all, we live in air-conditioned boxes. The destroyed natural habitat can slowly return to recovery, but it could take years to decades for that to happen. But unfortunately, it's not the case for vectors or pests, which seize the opportunity of high standing water. Before you know it, you've got mosquito colonies that can actually be deadly. So tree bark or pine bark infestation occurred after Hurricane Katrina in Mississippi. Again, the trees that are nailed by the hurricane force winds and the salt spray makes them weak and vulnerable to the bark infestations. And here's what I really like to look at. Look at the beautiful landscaping and all these pretty green trees in September 1998, Bay St. Louis, Mississippi. And look at after Katrina. The grass is now brown. The trees are debarked and deleafed, and they're also brown. You can't see it here, but that did not recover right away, not only that year, but also for the next spring to come. But they've gotten better since then. But what a shame it is to see what happens when a major hurricane like that ravages the landscape. You can look here at what happened to the Virgin Islands, St. Thomas and St. John. This is a before pictures, August 25th of 2017. This is after Irma came through. That brown is real, folks. This is not coloration. They do add a little coloration to make it green, but most of this is naturally occurring color. That brown is also naturally occurring color. It just, salt spray is devastating in addition to everything else going on. In this case, a Category 5 hurricanes. The Chandeleur Islands in Louisiana, same deal. July 2001. Yes, it's a wetland and there's more of it, pretty green. But notice here after Katrina, there's a lot less of it. And the reality is there's less of it still because of rising sea levels. Hurricane Ike moving closer to home, 2008, same deal, the Bolivar Peninsula. People were building here. They built on sticks, but they didn't build high enough to handle a 20-foot storm tide. And so most of the houses, except for this one, last house standing, were obliterated by Hurricane Ike storm surge. Hurricane Harvey, before and after this area in Rockport, east of Rockport. Nice resort area, was pretty much level. Not destroyed completely because they did build it to withstand stronger winds and they elevated it a bit, but it took years to rebuild. And I do not know if they've rebuilt this since. It has been 4 years. Hurricane Irma, again, the Virgin Islands. This was Barbuda, where they had the eye wall of 185 mile per hour winds. These homes are not necessarily the poorest built in the shed, but they were destroyed and demolished after Irma went through. And then back on the U.S. coast, Hurricane Michael in 2018. This is Mexico Beach, Florida. Nice little resort area. All the homes are here. Afterwards, most of the homes are gone, mostly due to storm surge, which was a violent surge of high waves and powerful waves, as well as, I believe, 15 feet of surge height. But combined with the waves, most buildings didn't stand a chance. Although this one did, and there's another one that had breakthroughs that did make it through. So to finish off, we're going to talk a little about freezes and cold. I'm going to zip through this section to get through the pictures. So we all know what happens to our wildlife here. It's not acclimated. It can have a real big, difficult time of it. And a hard freezes can damage or kill sensitive plants. And sure enough, 1 year ago next week, that's exactly what happened, actually 10 days from now. We had 305 million to citrus. The final value for citrus was 360 plus another 110 to other crops, meaning 470 million. We think we can double that to nearly $1 billion in agricultural damage here in the valley, because that also includes thousands of ornamental plants. I talked about this last year. The royal or Cuban palms that were planted down here in the lower valley are basically all gone after that freeze. A record sea turtle cold stunning event with the most records since data rescues, since data kept, over 10,000 on the Texas coast. This is how the atmosphere worked, upper level trough of energy, but notice these lines of equal pressure here, or equal heights in pressure, these gray lines, they are pretty low for our region. I mean, getting down at this value is more typical of what you would see in Nebraska and Iowa, even towards the East Coast. And no, it was dipping all the way down here. And with that came some incredibly cold temperatures. These are in Fahrenheit, not in centigrade. The morning of February 15th, below -10 to -20, -10-ish around Amarillo, single digits all the way down to Austin. And then here we were in the teens to lower 20s in the valley. So I color-coded that the purple for the most impact across the nation of this kind of incredibly hard freeze. So the St. Valentine's Day massacre in my neighborhood, these are certain palm varieties that lost their fronds. I think this tree may have recovered, but if it was a young Cuban, and I think it was a young Cuban, it didn't make it. These Cubans are behind my house back here, and they did not survive. If you look behind my house now, which used to be some beautiful palm trees, is now a moonscape. The citrus got lost. We had, as I mentioned, hundreds of millions of dollars in damage to citrus plants, as well as the blooms for the next season, which were starting to come out because it was mid-February, not early February. Much of the fruit, though, was recovered early before it hit the ground. 200 million was pulled from the trees in dollar value. So some savings was done too. These are the sea turtles at the South Padre Convention Center. I think they rescued 6,000 to 7,000 there alone. The surf temperature and Laguna Madre temperature got down as low as 34 to 38 degrees. It did not freeze, but it came awful close to doing it. I want to show this one slide because this was February 15th where we broke an all-time record in Brownsville that dated back to 1895. Everywhere else with shorter periods of record had a 10+ degree break of the record. Not just because the temperatures were cold, because they occurred so late in the winter season. February 15th down here is typically spring, and that was not the case in 2021. I'm going to zip through the next slides. We don't have much time left. I'm not going to talk about the 2011 ice storm, but I will show some pretty pictures of the 2017-18 winter, which included this beautiful ranch snow event, 3 to 4 inches of wet snow weighing down the trees, but again, real pretty to look at in Agua Nueva. But we actually had 6 inches of snow near Falfurrias and closed the roads up there. So a stripe of very heavy snow from Zapata County through Falfurrias. A lot of times the snow does fall in bands like this. That band extended to Kingsville and even into Corpus. So 2017-18 was pretty crazy. We had 8 sharp cold snaps for a day-to-day change of 25 degrees or more. This year we're running up on 3 or 4, so not bad for this year, but 3 individual freezing frozen events, very rare, if not unprecedented, to have this many occurrences in one year. So that's a real interesting situation. February, of course, ended up in the top 5 warmest that year because we flipped the script from a very cold January, especially in the middle of the month, and December was pretty chilly, to a warm end to the winter. So there's your snowfall map. I think I should have showed that before earlier. There's your snowfall map. There's your band right there I talked about earlier. Zip on through that. This is the pattern. We call this a McFarland variation, where it drives down air from the pole, which can make us really cold. And this is what happened early December. We got below freezing in several areas, not very far below. But then you combine it with upper level disturbance diving in across northern Mexico, where it can pick up some subtropical moisture, which ultimately produced the snow that we saw. We watch for pelicans when we get the combination of strong winds, sharply falling temperatures, and some light rain on State Highway 48. We're watching for tomorrow too, but without the rain, we think we'll be okay, but something to keep an eye on if you do drive that highway. That same winter, we got an ice event on January 16th into early January 17th. This is how it looked outside our office. We had about 1/4 of an inch of accretion of ice, but it was a lot worse on the junction between Interstate Highway 2 and Interstate 69E. These tractor trailers and a few cars got trapped up there. The road was treated for icing, but unfortunately, the treatment ratio had changed on their way to provide the treatment several hours earlier when it was still in the 50s and 40s, and the temperature crashed to 30 degrees in just 8 to 12 hours. And it was too cold for the brine solution they used, and it was slip slide skating rink up there. And these vehicles were trapped all through the night into the next morning. Not a good day. So that's how it looked. We had some glazed ice early on the morning, or early on the day on the 16th, and then as the cold front really slammed the cold air in, literally dropping 33 degrees or more in the lower valley, we had another glazed ice event that was relatively steady across the Weslaco through Harlingen area, and that's what we just showed the picture of. And so that's how that was. I want to skip to a man-made disaster for sake of time. So I want to get a quick look at the upcoming forecast. So before I do that quick look, as we're getting close to the end of time, are there any further questions? You can speak them here, or we can pop them in the chat. We can save them till the very end. Any questions?
There was one that, are there other areas, I've lost it, that along the coast, are there any areas north or south of us on the coast that experienced deluges like the rain events you talked about, like the valley? If not, why is it common here?
Okay, so the simple answer to that is yes. If we were to extend the June 2018 events northward into the coastal bend, you would find very similar rainfall amounts that they experienced there. In the spring of 2015, particularly mid-May, we had some good rains here in the valley. I think we had 4 to 8 or 4 to 10 inches over the course of about 10 days. But in Falfurrias, I think they had 25 inches of rain. It flooded Los Olmos Creek and all its tributaries. And you get farther north, there was a widespread 15 to 20 plus inch amount on the coastal bend in the Middle Texas coast. So we're talking like Alice towards Corpus and Kingsville. But then that was also the year of the tax day flood, which is mid-April in the Houston-Galveston area, specifically Harris County and Fort Bend County. So indeed, the Texas coast can get its share of rate events unrelated to a named cyclone. We can always look at named cyclones too. We all remember Harvey, 60 plus inches maximum rainfall in the League City Dickinson area of Harris County. And then just 2 years later, Hurricane Imelda formed up very quickly. Not much in terms of wind, but I think there was a 50-inch contour or bullseye near the Golden Triangle region of southeast Texas along the Louisiana border. So yeah, you can go back in history and look at both tropical and non-tropical and find that there are big events, if not bigger events, farther up the coast than the valley. One thing that helps the valley from getting too much rain so far is the fact that the geography of the Sierra Madre, that downslope component of wind, tends to dry some of these tropical cyclones out. The reason 2018 was so efficient was there was no dry air to grab. It was all moisture in a thin line, relatively thin line from southeast to northwest that literally began in the Western Caribbean, very rich tropical moisture zone, and then migrated its way into the Bay of Campeche and straight up the gut to the valley. It never tapped into that drying air of the Sierra Madre. So we got that. Hurricane Dolly, same deal. And same with Hannah. They were both fairly tight storms, and they never had the time to tap into the dry air to the west, which is what Beulah did to some degree, and definitely what Allen did in 1980. The reason I mentioned Beulah is that it is possible in a reasonable worst case that we could see 30 to 40 inches of rain widespread from a tropical cyclone that sits and spins over us and doesn't tap the Sierra Madre for a day or two. And if that happens, I shudder to think what it's going to look like here. But to get 60 plus inches of rain here is virtually impossible due to that geography. So any further questions? I don't see any more in the chat. So I'm going to close out because I think it is 53 after the hour of 8, according to my Verizon clock. So let's close out with a quick look at the upcoming forecast that goes into early summer. The February forecast is really interesting because the second half of the month is showing it could get warmer. And that's kind of what you're seeing here on this lower left. It's actually saying that we have a 40% probability of above average temperatures when the month is over, which basically says to me, based on the top graphic, which takes you through the middle of the month, showing a 40 to 50% chance of below average temperatures, that we're going to have to flip the script around Valentine's Day. Okay, so if we flip the script, and that's still uncertain, then this could very well happen. But I will say this, if we don't flip the script, and we just go to near average or still a few degrees below all the way to the 22nd of February, we will not end up in the orange. We're going to end up either in the near normal, or we're going to end up slightly in below because we are starting off like this. The feels like temperatures come Friday and Saturday morning are bone chilling, and the actual ambient temperatures not shown are going to be in the upper 20s to low to mid 30s during the night and early morning, and the daytime temperatures between tomorrow afternoon and Saturday afternoon probably not getting out of the 40s. That's 30 degrees below average on the whole. And when you take 30 degrees below average and you put it over 3 days or a couple of 15s on either side on a month that's as short as February, it's going to put the monthly average all the way down at like -10 by the time we get to February 6th or 7th. And we only have 21 days to get ourselves out of that hole. So you need to have a really warm period for the last 15 days or 14 days to do it. Now, it's happened before, 2011, that's exactly what happened. The first half of the month, we were about 9 degrees below average. The second half of the month, we were about 9 degrees above average. And the month ended up right on the zero. But to go above is going to take a real Herculean effort if you don't see any warm up come the middle of the month. But for the rest of the season, talking about April and March, May, June, July, This is the result of the La Nina, as well as some other factors and persistence over years that we've seen that spring and summer has just been warm to, in some cases, much above average, which means going from warm to searing hot as we get into June and July. And notice the precipitation forecast. Below average is pretty solid here through May. That's the spring period. And it stays below average as we get into June. And even the tongue here of below average goes into central and north Texas into July. And if that happens, which is a dry month normally here, last year not withstanding, we could really see a rapid change from the moisture and the green that we see now in the valley to a drought condition of severe to extreme levels as we get into late spring, if we don't see a repeat of that great rain that we saw last May and June. If May and June end up dry like they were, like March and April were last year, this year, then we're going to see a big time drought coming in. And the worst thing that will happen is that all that fuel, the grasses and the brush and the trees that have grown very nicely due to the wet and even the warmth that we had in December will now become tinder for rapid wildfire to explosive wildfire growth. So we really hope that that doesn't happen if people are smart when it comes to incendiary devices, including vehicles parked on grass. So the forecast thoughts of the season, there it is, worsening drought into spring 2022, but again, delayed by just-in-time rains over here. And by the way, this could actually help the early to mid part of the growing season because there's plenty of water in the ground that will last at least into March, but we'll see what happens by the time we get to April. But early spring is the time to review these water plans for our municipal and ag folks because it doesn't take long. We saw the sun angle, we saw the wind, we saw the evaporation rates, and we saw the fact that we can go from flood to drought in a heartbeat down here. So let's be ready for that. We mentioned the wildfire spread and growth, and oh, voila, a few more freezes expected in February. Those are front loaded, by the way. We're literally talking in the next 3 to 5 days. But we did mention early March because with this pattern and that cold air still lodged up there in southwest Canada, all it takes is one atmospheric pattern to break it down and have it break free east side of the Rockies deep into Mexico. And we have actually had freezes in early March. So it is possible to see that happen again. So we got to keep ourselves attuned to that potential. And with that, that is not a new slide. So I'm going to end it here and go to my thank you screen. And I may have a minute or two for questions if you want to stay beyond mine, but thank you all again for this wonderful opportunity. I hope you all learned a lot. And if you have any questions, either verbally or in the chat room, please share them now. I can answer them. I can stick around a bit longer. Thanks a lot.
Thanks, Barry. Any more questions for Barry? He knows his weather.
I've got one. This is Tony again. Has experienced in the valley a storm that dropped 30 inches of rain in recorded history?
So in recorded history, the nearest event we had like that was the event in Camargo, which is south of Starr County in Tamaulipas. We think it was 30 to 35 inches of rain fell there. It rained about 20 to 30 inches in southwestern Starr and to the west side of, say, Mission Mcallen. This is back in 67. More like 25 inches there. There's a story from the Ramirez museum, the Ramirez exhibit that I think is in a museum in Harlingen now. What's at the Harlingen Library for years? That talks about how Dr. Ramirez and others literally airlifted 30,000 residents from the border regions of Tamaulipas and Starr County onto the U.S. side to get medical treatment in Starr County, I think in other parts of the valley, before returning them after the flood began to recede. There are images of 5+ feet of water there in that Camargo area. So now take that and imprint 30 inches across the valley from, say, Mission Mcallen to Weslaco to Harlingen. So take the I-2 corridor and imagine adding 12 inches to 15 inches from what we saw in 2018. And you saw the pictures of 2018, and now double that. That's your 30-inch amount. And now imagine taking another 10 inches on top for what's considered a high-end reasonable worst case. I don't know what that would look like here. I do know that the drainage improvements are helping, but if you're building neighborhood improvements that used to be a 1 in 5 probability event to now a 1 in 100 probability event, and you're looking at an event that's beyond the scope of a 1 in 1,000, then you're looking at the need to evacuate a lot of people out of the valley to get to some kind of safer high ground well north or northwest of the region here from what would be a tropical cyclone. So whether it's a depression, storm, or hurricane, that kind of event would have to be tropical because it needs to have that much moisture, that concentrated, and then stall on top of us for 2-3 days. So bottom line is that's your reasonable worst case. If it happens, I will say we are not ready, but we do try to look at it for future planning. And in fact, we're going to try to build that particular discussion into a forum at the South Texas All Hazards Conference. We'll see how that goes. But we really want to get our core partners across the emergency spectrum and public safety spectrum to think about that possibility. Because when you think about it and you can allocate some kind of resource mutual aid or planning tree or planning P, if you will, to get the kind of resources you need to handle that, then the better off. I like to call it the imagination, what's the word I had? Imagination devastation, I think something like that. How can you imagine a case that you've never seen before? You know, and it's kind of what happened last February with the freeze across the state. Really hadn't been seen in the modern era. So to a lot of people, it's like, we never thought this could happen. No, it can happen. Just like the LA earthquake is going to happen. Are they ready in LA for a catastrophic earthquake? You'd hope so. They are in Japan. But are we ready for 30 to 40 inches of rain? I can tell you right now we're not. But if we can imagine what the devastation could be like by doubling, tripling rainfall amounts we've seen in the past and then applying that to drainage, I think we can get something done and some kind of improvement without necessarily having to spend gazillions of dollars to do it.
Thank you.
Anybody else?
I'm sorry. I was trying to thank you for your talk tonight and I was muted. But the comments in the chat, everybody it's very interesting, awesome. Thank you so much. So your crowd on Groundhog Day loved it.
Excellent. Well, thanks everyone for sticking around for the hour and a half, and I appreciate the time as always every year, and hopefully we'll be through most of the COVID and we can be live again next year. But
That'd be awesome.
Regardless, we'll do it either way.
That sounds great. Thanks for spending your evening with us.